Hello everyone, this is Earth Science teacher Tim Martin, and in this video I want to introduce you to the geologic concepts of folding and faulting. When we look for faults and folds in the Earth, what we're really doing is looking for past evidence of plate tectonic motion. Let's take a minute to review the basic motions of plate tectonics. The first of the three motions is divergent motion. This occurs when magma comes up from deep within the Earth. This typically happens in the middle of the ocean. It generates earthquakes as the plates move apart from each other. This may also happen on continental plates as well. The next type of motion, convergent motion, happens when plates collide. Here we can see an oceanic plate subducting beneath a continental plate. As the plate subducts, it cracks and breaks, generating earthquakes. Finally, we have transform motion. This occurs where two plates slide or grind past each other. Again, this generates earthquakes. Now let's take a look at the structures identified with each of these three types of motion. To start off with, let's talk about rifts or cracks. When the Earth is pulling apart or forces are acting on it in opposite directions, the crust will thin, stretch, and possibly crack. These cracks are often known as rifts. This is caused by tension or divergent motion. A normal fault also happens with tension or divergent motion. If the rock is more rigid and less likely to stretch, it may simply crack, and when it does, one block may drop lower than the other. This is what's called a normal fault. Opposite the normal fault, we have a thrust or reverse fault. This occurs from compression or convergent motion. When two plates are pushing against each other, one plate may go down or another one may go up. This creates a thrust or reverse fault. Finally, a transform fault or a strike-slip fault occurs with lateral stress. When two parts of the Earth's surface are moving in opposite direction with respect to each other, one may slide, causing a transform or a strike-slip offset. While sometimes rocks break with faults, sometimes they're soft enough to fold. A fold occurs with compression or convergent motion. Sometimes rock layers may fold with an upward bend, other times they may form with a downward bend. Both types of folds occur with compression or convergent motion. An upfold is referred to as an anticline. The downward or U-shaped fold is referred to as a syncline. Let's take a look at what this looks like with real geology. Can you identify the motion from these real images? Let's take a look at these 5 different features. Thingvellir National Park in Iceland is one of the classic locations where the Earth is splitting apart. On the right-hand side of the picture, we see the North American plate. On the left side, the European plate. As the plates are splitting apart, this rift or gap is opening up. This occurred through divergent motion. This picture of the Hayward Fault was taken in Fremont, California, in Central Park. You can see when the road planners built this road, they didn't intentionally offset the sidewalk and curbing. What happened here is part of the road was built on the North American plate, and the other part of the road was built on the Pacific plate. Here's the fault line, and we can see the further section is moving northward, where the side that the photographer is standing on is moving towards the south. Moab Fault is a dramatic fault that was revealed in a road cut just outside of Arches National Park in Utah. Here we can see several very large faults. As we identify the previously aligned layers, we can see that this brown stripe used to all be the same layer, but now has been offset with several normal faults. This represents divergent motion or tension. Browns Canyon of the Arkansas River goes through Salida, Colorado. Here we can see rock layers that have been folded. This must have occurred through compression or convergent motion. It's impossible to make a fold by pulling. Going from a large scale to a rather small scale, in Mosaic Canyon in Death Valley National Park, California, we can see this small layer was offset. The fault indicated in red, and these yellow layers are offset with a little bit of overlap. This indicates that this was a reverse fault caused from compression or convergent motion. So let's take a little quiz. Can you identify the motion in these next 5 images? Feel free to pause the video between each image. Number 1 is Katobe Knob, located in the Cedar Mountain Recreation Area in the San Rafael Swell in Utah. Number 2 is a rock structure that I found at Noosa Heads in Queensland, Australia. Number 3, a road cut near Orderville, Utah. Number 4, rock layers west of Wild Rose Campground on Wild Rose Road in Death Valley National Park. Number 5 is specifically called Earthquake Fault, located just outside Mammoth Mountain Ski Area in Mammoth Lakes, California. So, could you identify all 5 of these images? What sort of plate motion caused each? Are they normal faults, reverse faults, folds, or rifts? Let's take a look at each. Number 1, Katobi Knob in the San Rafael Swell in Utah. First, we identify the fault plane, located here. Then we identify the layers that used to line up, here and here. So we can see, because of the overlap, this must have formed from compression or convergent motion. Number 2, Noosa Heads in Australia. Again, the first thing to do is identify the fault plane, located here. Then the layers as they used to match up, here and here. Because of the lateral offset, we understand this must have been transform or a strike-slip fault. Number 3, again, this is a road cut in Orderville, Utah. Let's identify the fault plane, leaning from left to right across the image. See the double brown lines towards the bottom of the image? These used to match up with each other. Thus, this is a normal fault, formed through tension or divergent motion. Number 4, along Wild Rose Road in Death Valley National Park. We can obviously see folds. These folds must have formed from compression or convergent motion. Finally, number 5, the earthquake fault near Mammoth Lakes, California. Again, this is a great example of a rift where the earth was experiencing tension and cracked open, causing this split in the rocks. Would you like a little more practice identifying folds and faults? You can download a slideshow of images that I've taken from around the world of places where we can see convergent, divergent, and transform plate motion. Thanks for watching, and I hope to see you again on another TMart Science video.